This is a CCEA GCSE Mathematics. So this is M8 paper 2. This is the one with the calculator, and it's from November 2022 series, and this one's actually on Thursday the 1st of December. And this will be looking at question 1. Simplify t cubed times t to the power of 8. So in this scenario we add the powers, so we would get t to the power of 11. T squared all cubed, that's like t squared times t squared times t squared, so it'll be 2 plus 2 plus 2. We just do 2 times 3 here, so that's t to the power of 6. And then t to the power of minus 3 all over t squared is minus 3 take away 2, so that's going to be t to the minus 5. You could write it like that, or you could write then 1 over t to the power of 5. Show that 20x minus x cubed equals 1 has a solution between 4 and 5. So we're going to substitute in then whenever x is 4. So whenever x is 4, we're going to get 20 times 4 take away 64. So that's 80 take away 64, which is 16. Whenever x is 5, we're going to go 20 upon 5, take away 125, so that's 20 times 5, which is 100, take away 125, then is minus 25. So the fact that whenever x is 4 it's 16, and whenever x is 5 is minus 25, and that 1 is in between those two numbers, then there's a solution between those. Use trial and improvement to find this solution correct to 1 decimal place. So a reasonable place to start would be kind of halfway in between. Quite often in this, it's maybe just in the M7 papers, it's kind of set out as a bit of a table. That might help. But our x value, so we're going to start it with x then equals 4.5, and then we have 20x minus x cubed. So let's go for then 20 times 4.5, take away 4.5 cubed, and that gives us minus 1.125, which is obviously too small. Now this is a bit of a weird one. If we go 4.6, weirdly enough, we'll actually get a smaller answer. So you could realise you're going the other way. I guess that's what makes it M8. So it's just a wee bit kind of tougher to work that out. So if you try 4.6, you'll end up with minus something to kind of something smaller. So we're going to go x then is 4.4. And that gives me 2.816. And that then is too big. So we need to check halfway in between, which is 4.45. 20 times 4.45, take away 4.45 to the power of 3, and that ends up with 0.878, which is too small. So we need, weirdly, we need it in between this and this, so it's then going to be 4.4. It's quite confusing the way that works out, so our answer in this scenario then is going to be 4.4. Rearrange v equals u plus at to make a the subject. So I'm going to take away u from both sides. That gives me v minus u equals at, and let's keep those separate so we can see. And then we're going to divide by t. V minus u over t equals a. So a equals v minus u over t. Spinner is spun 1,000 times. The table shows sum of the number of times it landed in the number 3 and some of the calculated relative frequency values. So after 20 spins it was 2. That's obviously 0.1. 200 spins it was 26. 0.13 500. So calculate the missing relative frequency. So our missing relative frequency then is going to be 64 divided by 500. That gives me 0.128. That's okay. Calculate the number of times it landed on a 3 for 1,000 spins. So we're going to do then 1,000 times 0.1. Hopefully it's quite obvious what this is going to give us. It gives us then 122. So missing relative frequency value. Sorry, I don't know if they want an answer in here. I've just actually subbed it in. And then that's 122. Use the best relative frequency value from the table to calculate the number of times you would expect to get it in 2,500 spins. So the best one is always the one that's kind of appeared the most, so it's going to be this one here. So either just times this by 2.5, because 1,000 goes into 2,500 2.5 times, or times this by 2,500. And we get then 305. Question 5. Calculate your answer in standard form. So we can just stick this into the calculator. So I'm using this button down here. Which then is 176.4 is my answer. Putting that in standard form, then it's going to be 1.76 times 10 to the power of 2. This one here, so 2.5 times 10 to the power of 6 times 4.8 times 10 to the power of x equals a times 10 to the power of 4. So my a needs to be in standard form. Well, they haven't told us that, but let's assume that it is in standard form. 2.5 times 4.8, and so the answer there is 12. So in this case then a is going to be 1.2. And if we're timesing it then to get this, kind of gets a wee bit confusing here. So 10 to the power of 6 times 10 to the power of something then gives me our 10 to the power of 4. So let's write it out and see if we can work it out. So 12 times 10 to the power of 6 plus x is 12,000 is one way of working it out. Let's see. Okay, so where have I got that from? The 2.5 times the 4.8 gives me 12. 10 to the power of 6 times 10 to the power of x gives me 10 to the power of 6 plus x. And then we've just worked out that this was 1.2, so it's 1.2 then times 10 to the power of 4. So we can then set this up. Again, that's 1.2 times 10 to the power of 4 if you want to do it like that. And then if you want to do 1.2 times 10 to the power of 6 plus x plus 1. Now do you see what I've done there? I've kind of moved that along one. So we have that. So we have 6 plus x plus 1 equals 4. And then that gives me x is minus 3. A couple of different ways you can just kind of play around with it and see if you can get it to work out. So my a then is 1.2 and my x is minus 3. For his morning run, Tony goes to the park by one of 3 different routes. In the park, he chooses one of 8 different circuits to run. In how many ways can he go to the park and complete this circuit? So 3 different routes and then 8 different ways to run. So that then would be 24. Describe fully the single transformation which maps triangle A to triangle B. Well, it's obviously not a rotation because the thing's not the right way around. It can't be a translation. It's not an enlargement of any sort, so it's going to be a reflection. And hopefully we can see the inner line of reflection is this. It's just easier to turn this around. Apologies, it looks a bit off now on the screen. But it's a reflection there. So what's that line? That's the line y equals x. So we need to write that in. Draw the enlargement of B using scale factor 1/2 and centre minus 2, 0. So the centre is going to be here, and it's an enlargement of this scale factor a half, so it's going to get half as big. So minus 2, 0 was here. Instead of going 1, 2, 3, 4 squares, I'm going to go 2 squares. Instead of going 1, 2, 3, 4, let's say 1, 2, 3, 4, 5, 6, 7. I'm going to go 3.5. 1, 2, 3.5. And then across 7 up 1 is across 3.5 up a half. And so we end up then with something like that. So that's my scale factor a half in there. Simplify x to the power of minus a half, x to 5 to the half. So that's x to the minus a half multiplied by x to the power of 5 to the power of a half. That is x to the power of minus a half multiplied by x to the 5 over 2, because we multiply those two powers there. Now we add the power, so it's 5 over 2 take away a half, or plus minus a half. That just gives 4 over 2. So my answer then is going to be x squared. Question 9 and B are similar models of a pyramid. The base area of B is 21% larger than the base area of A. By what percentage is the height of B larger than the height of A? So if you add 21%, so it's going to be, sorry, if you add 21%, it's going to be, well, whatever way you want to do it, 1 to 1.21. So if I multiply this by 1.21, I get that one. That's my areas. And so to find then my heights, I need to take then the square root of 1 and the square root of 1.21. Which gives me 1.1. So 1.1. So 1 to 1.1 is then going to be 10%. I hope you can see that. So what do you multiply this by to get this? For 1 is obviously 1.1, so that's 10%. That was a silly thing to do. Probability that Orla has a puncture on her cycle ride to school is 1 over 50. That's not great odds. Probability there's a traffic diversion is 1 over 20. Complete the tree diagram to show this information. That's 1 over 50. That'll be then 49 over 50. Probably there's a diversion is 1 over 20. So that's 1 over 20. That means it's 19 over 20 and 19 over 20. What is the probability that Orla will be delayed by at least one of these two causes? So it will be that one, that's a puncture and a diversion, that's at least one. Puncture, no diversion. No puncture, diversion. And then it's not that one, so it's going to be those three there. There's a couple of different ways of doing it. I think it's easier if we do this one here. So I'm going to multiply 49 over 50 by 19 over 20 and then take it away from 1. 1 minus 49 over 50 times 19 over 20. Is that 931 over 1,000? Yeah. And take that away then. I get 0.069 or 69 over 1,000. Question 11. AB is 32, ABC is 55, CD is 21, BCD is 29. Calculate the size of the angle CBD. So what are we going to have to do here? We're going to have to use trig to find the side BC using SOHCAHTOA here, and then we're going to use this and use maybe the sine rule to work out this angle here. So let's take this triangle first of all. 32, 55, and I want A here, this is H, so I'm going to use cos. Cos x is A over H, cos 55 is A over 32, A is 32 cos 55, which is 18.3544. Then take the other triangle. We know that we're trying to work out this here, and we know that's 21, and we know then that's 29. We have to find that, and that's okay. So I'm going to go for sine x over 21 equals sine 29 all over 18.35445, because we know that's our 18.35445 there. Hope that makes sense. So that's my sine rule then. It's easier to work out the angle one if you put the angle on the top. So my sine x then is sine 29 all over 18.35445 times n by 21. So I type that then in the calculator. I'm going to set it up like that I can. Sine 29 on the top. Well, I'll work without the bracket. Keep safe. 18.35445 equals, and then I'm going to times that by 21 equals. So my sine x is 0.554688. Shift sine answer equals, and my answer then is 33.6 degrees. Sorry, 33.7 actually, so 33.69. There eventually. Question 12. In a triangle PQR, angle P is acute. PQ is 11, PR is 8. The area of the triangle is 22 centimeters squared. Calculate the length of QR. So we're going to need to do a couple of different things here. We're going to need to use the area of our triangle formula to work out this angle here, and then we're going to use the cosine rule to solve then from there. So area is a half AB sine C. So that means 22 is a half upon 11 upon 8 sine P, which is going to be this angle here. Sine P is 22 over a half upon 11 upon 8. So that gives me a half. That's quite handy. And I do then shift sine, which is going to give me then 30 degrees, just to show you. So P then is 30 degrees. I now know two sides and the angle in between, so I can use the cosine rule to find this. So QR squared is going to be 11 squared plus 8 squared minus 2 upon 11 upon 8 sine 30. So QR squared is going to be 121 plus 64. Take away, I think that gives me 88. I hope. 121 plus 64 equals, take away 88 equals, I've done something wrong. Sorry, it's the cosine rule. I'm losing my mind here. It's cos of 30. means of course that's not 88. Use the sine of 30 was 88. That's the cosine rule we're using. Close. So 2 times 11 times 8 times cos of 30. And that gives me 152.42. There's a look. So 121 plus 64. Take away 1. Gives me then 32.58. So QR squared. 32.58. Got there eventually. And then QR then is the square root of that, which is 5.71. Question 13 then. An envelope contains 6 yellow paper clips, 4 red paper clips and 2 white paper clips. 2 paper clips are taken at random. What's the probability that they are both red? So there are 12 in all. So the probability of red, then red. So the probability of the first one being red is 4 over 12. The probability of the second one being red is 3 over 11. So that cancels with that, and I end up then with 1 over 11. What is the probability the 2 paper clips are different colours from each other? Well, we can do this a couple of different ways because there's different wee options. You could do a tree diagram where you've got yellow, red, white, and then you have a lot to work out there because it ends up being 9 different options. But of the 9 different options, then we want 6 of them, so different colours. So what I'm actually going to do is the probability of 2 reds, the probability of 2 yellows, and the probability of 2 whites, and then subtract them then from each other. And of course I already have red and red, so my probability of red and red I know is 1 over 11. That mightn't be that nice to work out, but that's okay. Probability of yellow and yellow, so that's going to be 6 over 12 multiplied by 5 over 11, which is 30 over 132, and the probability of white and white is going to be 2 over 12 times 1 over 11, which is 2 over 132. So let's just times that up then again by 12. So then it'll be 12 over 132. So those are my 3 probabilities. So 12 plus 30 plus 2 over 132 is of course 4244. They both divide by 11. In fact, that goes, does it? That's a third. Because that 44 goes into that, it's just 3 44s, just give you that, so it's a third. So that means the probability of different colours is equal to 1 minus a third, which gives us 2/3.